Hi everyone. In today's lecture, I think I might have rushed through this with the idea with the explanation that I gave for networks, the different kinds of wireless networks. So I thought I'll make a short video discussing all these networks in probably in a slower manner than what I did in the lecture. So first, briefly, to just discuss why did this concept of networks come about and what is the difference between a wireless and a wired network. So if you understand, in 1980s, that's when we started having internet. So meaning we had an interconnection of computers. So then let's say we had some n number of computers. What is the best way that I can connect those computers such that the information flow is maximum between the entire network? The network, when I'm using the word network, the entire combination of computers. So that's what they termed as networks. Okay. And now the purpose of this lecture is not to explain to the different kinds of networks. If you have taken any course on networks or you can just read up about it, there are different kinds of networks, how to route a set of computers. You can, so if let's say you have some n number of computers and you can actually have different ways in which information can flow between one computer to another computer. So there are different architectures in which it can flow. There is mesh, ring, star network. So there are different ways in which it can flow. That's not our focus here. Okay. So these are all wired networks because physically a wire has to connect. So for example, if I want data to flow from one device to another device, a wire has to physically connect it. Okay, let's say if there are some 100 devices in the system in a room and you want all the devices to be connected, they all have to be physically connected using a wire. So there are certain rules and regulations as to how can this information flow from machine to machine. Okay, so that forms the rules for wired networks. In case of a wireless system, it's a completely different ball game. For example, in a wireless system, let's say there are a lot of machines. Once you transmit power wirelessly, anyone can receive it. Okay, there is no wire connecting them. Anyone can receive it. Secondly, when you transmit a power wirelessly, you are actually an antenna is radiating energy from a mobile device or any computer also. Okay, once it is radiating energy, this energy theoretically it can travel infinite distance, right? I mean, it's just an electromagnetic field which can propagate till infinity. The only difference is the power will become so feeble that it will be undetectable. It will be almost close to zero for very long distances. So when I say I'm going to talk about a wireless power transmission or a wireless network, I have to also mention the distance because theoretically it's infinity. The power can be received at any distance you move away. Okay, but when I say power received, the power received power should be good enough. So that's why what is good enough we will discuss in the later part of the course. Okay, so here the point is in wireless network we also mention distances. We don't mention in a wired network because in a wired network you physically connect it using a wire. So the length of the wire will be the length of the distance of coverage. It's simply equal to the length of the wire. But that's not the case in wireless. In wireless, signal can be received anywhere. Theoretically, for example, if a tower is radiating energy, it can go all the way till infinity. The only difference is the power will reduce by the rate of 1 by r square. We will discuss why does it reduce as 1 by r square later. But it reduces as 1 by r square. Eventually, it will go to 0 at only t r equal to infinity away from this tower. Okay, but we have to define in a certain range. In a certain range, this power is going to be effective. When I say effective, what I mean is you can actually have a reliable communication between say two devices in that range. Okay, so if I'm transmitting some bits, you should be able to reproduce the same number of bits at a different device with good accuracy. So that's what I mean by reliability. So the whole of wireless communications, we can just club together and just put it in two simple words. How far and how fast. What is the maximum distance you can transmit the number of bits and how fast can you transmit it? Okay, so these are the two constraints. In fact, this determines there is some other thing called power, power and cost. Of course, they are all related terms. So the question is if you want to transmit for longer distance, then you have to transmit larger power. Okay, and cost also goes high because you need to build, you need to keep charging the system again and again. So they are all related parameters. So fundamentally, you can just put the idea, the whole course of wireless communications in just two words: how far and how fast. Okay, how fast meaning what is the data rate at which this data can be transferred, and how far, what is the distance to which the data can travel. Based on that, we are going to classify a set of networks. Okay. Again, why do we have so many networks, so many protocols and all that? So what is a protocol? Essentially, when two devices are, for example, when two devices are talking to each other, there are only two, let's assume there are only two devices in this entire, in the system that we are considering. Then the information, this can simply transmit data in any band it wants, and the receiver can also tune it to the correct band and receive the signal. But if there are many number of devices, then like a traffic rule, we all should agree upon a common standard. So that's why we have standards. Okay, so we all agree upon a common standard. Okay, if this is a standard, this is the bandwidth you should use. So we all agree upon a common standard. So that's why we need standards. Okay, otherwise there will be unnecessary, like traffic collisions. If nobody follows traffic rules, then there will be accidents. So similarly, we need to follow certain rules and certain standards. So we will be giving certain band of frequencies which a certain standard will occupy. Okay, and there are also power levels, which I'll talk about in a few moments. Okay, so the question remains, how far and how fast? So we'll see different networks based on this same parameter, how far and how fast. So this graph here, this picture here actually shows different networks classified based on their distance and speed. So I just said how far and how fast essentially is nothing but distance and speed. Ideally, as I said, it's a wireless system. If you are transmitting any power wirelessly, it can travel infinite distances. But the question is how reliably you can receive that power and decode it. For example, I have some 1 gigabit of file with me. I am transmitting it to a certain location. Now, if I tell you I want out of that 1 gigabit only 1 bit can be in error, then you need a certain power level to be received. Okay, that puts a constraint on the power level that you can receive to make a good decision on the I'm just using word, I'm assuming that it's mainly for COMSYS audience, but since there are some of you who have taken E&I, I'll also be posting some videos on COMSYS very soon. I'll do that. So let me get back to this here. So if I have a data to be transferred, 1 gigabit of data to be transferred, the question is how fast can I transmit this data? Okay, so that data determines my speed. It can be 1 Gbps. So within 1 second I transmit all the data. Okay, or in 1 nanosecond I transmit 1 bit. So that's what this 1 gigabit is mean. So here I have 1 gigabit of data. Okay, approximately 1 gigabit is 10 power 9. So I can say in 1 nanosecond I will transmit 1 bit. Next question is how far? How far can you ensure you can transmit it? So these are the two important parameters that you have to mention in any standard. So based on these two parameters, how far and how fast, we have classified a set of standards and we have also called them as networks. Okay, so anytime there are devices and there is information flow between a set of devices, we call it as a network. Okay, when they follow a certain rule, we call that a network. Again, I told you this concept of network is all borrowed from a wired internet systems, okay, which originated in 1980s. So first, the smallest of the network is what we call as personal area network. So this personal area network, approximately here it's written here, it works for around distances less than 10-20 meters. So that's the distance it works for. So common examples of personal area networks is Bluetooth devices. So most of the speakers and earphones and even a lot of the smart pens which are being used with tablets and phones, they are all Bluetooth. Most of them, they use Bluetooth standards. The maximum speeds for Bluetooth now it is around 2 to 4 Mbps, okay, megabits per second. So that's the speed of Bluetooth, and the distance it can cover is 10 meters, approximately 10-20 meters. So this is the number. Okay, and Bluetooth is a very popular standard. That's why I've mentioned Bluetooth here. There are also standards called Zigbee, which is gaining momentum for smart homes. When you want a smart home where all the devices are connected to a network and they are all interacting with each other. So it's a very short range within a house. You want the devices to connect and interact. Okay. So in such applications, we call that network is called Zigbee network. And this is also close to, it's right now it's 480 kbps speeds. Okay. So these are all very low data rate, short range. So these are the words I'm using: low data rate. The speed of the data is less, and short range. The distance it's going to occupy is also very short. It's less than 10-20 meters. Okay, so within a household environment we can use it. So I've shown it here. So this is a classic example of a personal area network where a Bluetooth device, a laptop here, can connect via Bluetooth to a mouse. It can connect to a mouse or another laptop through Bluetooth, or a cellular phone, again an earphone, or a printer. Okay, so this is one classic example of a personal area network. Bluetooth is one good example. Again, as I said, Zigbee is also one evolving standard for smart homes. Okay, and as I said, ultra wide bandwidth is slowly gaining momentum recently. As I said in the class, by 2013 it was more like we didn't see any popular products in a commercial products in it, but it is gaining momentum. It is believed that it can offer higher data rates in the future. Okay, but there is no proper guarantee there. The next is LAN, local area network. Okay, this again, local area network is the next level of wireless network. See, again, all these networks are wireless networks. As I told you, that's why we are mentioning the distance. Otherwise, if it's a wired network, you just need a cable. Whatever the distance the cable comes, that will be your distance. That's not the case with wireless LAN. Wireless LAN can be pretty longer. Okay, a wireless network. Okay, now a LAN or a local area network that covers around 150 meters. That's what is I've written it here. So 150 meters, and speeds, again, this speed 11 to 54 Mbps. So the popular example of LAN, 50 Mbps speeds, it's your Wi-Fi. So today most of the free internet that transfer happens through Wi-Fi networks. Okay, so for example, if you look at this system here, so what is shown here is you have a main router. You have a main router which is connected through wire to different local routers here. Now this router you can locally connect to a Wi-Fi network. All laptops, phones, tablets, they can all connect to a Wi-Fi network. Now let's say, for example, in our campus there are different Wi-Fi hotspots or Wi-Fi routers. So when I move from one region to another region, I'm going to connect to a new Wi-Fi hotspot. Okay, I'm going to connect to a new router. So this is the way it works. So this is I mean, this coverage is slightly more than Bluetooth. Now what distinguishes the coverage? That should be your natural doubt. How is that this is covering more distance compared to Bluetooth? The simple reason is transmit power. For example, I'll just give a number. For Bluetooth, the transmit power is of the order of 1 milliwatt. Okay, that's the order of power that's why Bluetooth is also called Bluetooth low energy. That's a new standard which transmits very low power. It's of the order of 1 milliwatt. So that's why I often say that especially when you're having a long phone call, it's preferred that you use a Bluetooth ear headset, because Bluetooth transmits just 1 milliwatt of power. Your cell phone, on the other hand, it transmits 1 watt of power. So if you are keeping your cell phone very close to your ear, the power amplifier is actually transmitting 1 watt of power. It for a longer distance you might feel hot around your ear for a longer calls. So if you have a Bluetooth headset, go for it. Okay, because it's going to transmit less RF power, 1 milliwatt of RF power. In case of wireless LAN, the power levels are of the order of 100 milliwatts. So this is for 2.4 gigahertz range. So in this lecture I'm just introducing you to the concepts of different wireless networks possible. Okay, again, this course is not a course on networks. We are just briefly introducing different kinds of networks, and then we will then talk about individual networks. Okay, so this is called wireless LAN. So in the wireless LAN network, wireless local area network. So if you remember, when we were students, when we had the first time, we didn't have Wi-Fi in colleges. So we used to have only wireless, local. There was no wireless LAN. It was a direct LAN cable that used to come to each of our rooms. Okay, so there was a local hub. From there we used to get all this. This local hub was actually a wired connection. We used to have a wired connection here. Okay, now the data rates are so high for Wi-Fi that we don't need that wired connection anymore. Okay, so Wi-Fi has done a big service, because you could actually have internet on the fly. We could have just routers everywhere, and it gives you can just walk around the campus or any place and have good internet access, very high speed internet access. A lot of internet today flows through Wi-Fi. Okay, the only reason why the range is larger for a Wi-Fi compared to Bluetooth is because of the transmit power. The transmit power is much higher, nearly 100 times higher for Wi-Fi. That is the reason you get almost 10 20 fold 10 fold distance increase. Okay, so yeah, so as I told, power reduces by distance square. So if I want to increase the distance by 10 times, then you'll have to increase your transmit power by 100 times. So that's a 1 milliwatt to 100 milliwatt difference comes there. Okay, so that's about wireless LAN, and we discussed. So I'm not using a word, some jargon. So for example, the standard is 802.11 ABG. So these are just the standard names. We will talk about what are these standards, what are the frequency bands they use, and all that in the probably in the next week of the lecture. Okay. The third network is called metropolitan area network. So again, here there is a very interesting story. For example, what happens is that especially one of my professors that once told me this very interesting story in IITs. So in 1980s, when they had landed in IITs, there was no telephone connection inside the IIT campus. So there was a wired, because when you want to give a telephone connection, you literally have to lay a wire completely. Okay, you have to lay a physical wire all the way to your house, and then you get the telephone connection. The problem was, the inside the campus, the wire has to come almost 2 to 3 kilometers inside. Okay, that was the problem that they faced, or even little less than a kilometer, but nearly, or let's say 1 to 2 kilometer. That's the distance that this wire had to reach, and for that they were taking much longer. So the professors, they wanted to solve that problem. So what they did was, from this point they took this signal, the wired signal, and then had a small transmitter here. Okay, now this transmitter could actually transmit. They designed a transmitter which can cover up to 1 to 2 kilometers, and in their house they just had another receiver here. Okay, and that could receive these phone calls. So this problem was called WLL, wireless local loop. Okay, this kind of solution, where sometimes the telephone lines cannot reach some interior region, and it becomes too expensive, or there isn't enough infrastructure to take it deeper inside a certain place, then we can use wireless technology to provide telephone or even internet access to remote areas. Okay, so such concept is called wireless local loop, and one of the more popular such standards is, it's called WiMAX. Okay, and microwave access, there is an expansion for it. We'll come to that when we talk about the standard in detail. So WiMAX is a standard which was mainly targeted for remote areas, when there is a remote area, and WiMAX can connect for it. So the range was slightly less than the cellular tower range. Okay, it was of the order of few kilometers, less than a kilometer. So that was the distance for metropolitan area networks, or MANs. Okay, so WiMAX is one popular standard. Wireless local loop, as an idea, it was also very popular idea. Okay, so whenever, especially in remote areas, when it's difficult to take your wire all the way to the houses, individual houses, it becomes very difficult to do that. In that place, you can simply have one big tower transmitting power, and each house can have a small receiving tower at their local houses. Okay, so then that problem can be solved. So you don't have to lay wire all for 1 or 2 kilometer distance. So this is one big application of, in fact, the reason why wireless took over compared to a wired system is because of this reason. I also discussed in the class, there is something called as last mile problem. So especially telephone network operators used to feel this problem, because once they bring telephone connection all the way into a very densely populated region, it became difficult to properly route it to each house. Okay, and most of the bandwidth, so for example, they used to bring this cable. I mean, let me talk about internet. It's even telephone, and it's true even for internet. They used to bring these connections through optical fiber cables. They used to offer very wide bandwidths. The moment they enter the households, very close to the households, now the paths become far more convoluted, and they had to use twisted copper wires. Now twisted copper wires were low bandwidth wires. They used to have the bandwidth of the order of 4 to 5 megahertz. Okay, so once they go to such low bandwidths, your data rates were reducing. So wireless local loop, or WiMAX, could be a good solution in those places. Okay, but now we have wide area networks, which is your popular cellular towers. they are taking care of it, and they are almost ubiquitous now, so we don't really need for a man right now. Okay, so the next thing is wide area network. These have few kilometers coverage. In fact, this was in the past when cell towers were supposed to cover several kilometers, but now if you see, almost every 500 meters, 400 meters, every 500 meters to 1 kilometer, you find a cellular tower. Okay, and the reason why we had cellular tower is to provide better data rates, higher data rates to more number of users. That is why if you want to serve more users, then you need more towers. So if you need more users, then the number of towers also go high. Okay, we will talk about this when we talk about cellular how does information flow in a cellular network. I'm just here introducing the different terms. So this is for, and all your 1G, 2G, the 3G, all these networks, all these protocols, they are all cellular networks. Okay, and this is for wide areas. And the speeds, again, cellular speeds, I don't think I need to explain the speeds of, okay, let me just go back to Wi-Fi, because I forgot to mention the speeds here. I mentioned the distance that Wi-Fi can cover, but not the speed. So Wi-Fi speed has been an ever evolving speed. So for example, Wi-Fi was started in late 1990s. Okay. And after that, at that time, it was few kbps. The speeds were around few kbps. Then slowly we came to 10 mbps in 2000s. And finally 100 mbps in late 2000s, 2010s and so on. And now there is something called Wi-Fi 6, which is actually targeting a speed of the order of few gigabits per second, gbps speeds. Okay, so that's the increase in speeds we are targeting. So Wi-Fi now is becoming very high speed. So most of the internet, that is why it's flowing through Wi-Fi, and it's also cheap. That's other reason. Okay, for a cellular network you have to pay for it. Okay, whereas a Wi-Fi is a more of, you get it for free as well. And WiMAX, I'll not talk about WiMAX because it's not so popular, but yes, speeds are pretty good in WiMAX. And for cellular networks, this is something we have been using. So we know from when you began with the GSM phones, they used to offer 10 to 20 kbps speeds, around 10 kbps speeds. This is around 2G. Then I think we went to around 200 to 300 kbps speeds. I may be off, the number may be a little bit off here, but it's in the ballpark, 200, 300 to 400 kbps speeds. Then we moved to few megabits per second, mbps, and then 10 mbps, and 4G is promising 100 mbps. This is the maximum speed you can get. Okay, under ideal conditions, maximum speeds. So it will always be lower than this, 10, 100 mbps. And in 5G, we are planning to give you close to gigabits per second speed, gbps of speeds in 5G networks. So this is wide area network, and we are also evolving here. And the distance it covers is around few kilometers. Okay, that's the intended distance coverage. Also, the transmit power is of the order of a watt. 1 watt is the transmit power. Now, how do you actually characterize transmit power? I will probably discuss it in a regular class. Okay. And finally, regional area network covers an entire country. Okay, it can cover an entire country or a continent. And this coverage is done through satellites. So this also has very large coverage, satellite phones, especially when you're in the middle of a sea or somewhere, you can't have a tower connection. So in that case, you can be connected through a satellite, and you can have a satellite a satellite network routed, and you will have a connection through a satellite network. Okay. So these are the main classifications of networks. Okay. In the next few lectures, probably I'll make a few more videos on basic introduction to mobile, communication systems, because some of you are from ENI. So I thought I'll make some videos on communication systems, basics of communication systems, which will help you understand the subject better.